Let's continue. Lesson 3, Part 2. Why do metals have high melting points? The properties of metals are related to their structure. Metals often have high melting points and boiling points. Gold, for example, has a melting point of 1064 degrees and the boiling point of 2807 degrees. This property is due to the strong attraction between the positively charged metal ions and the share of electrons. In metal extraction and other industrial processes, furnaces often run continuously to maintain the high temperature needed to work with molten metals. And how do metals conduct heat and electricity? Delocalized electrons in metallic bonding allow metals to conduct heat and electricity. For example, when a metal is heated, the delocalized electrons gain kinetic energy. These electrons then move faster and so transfer the gained energy throughout the metal. This makes heat transfer in metals very efficient. Delocalized electrons also conduct electricity through the metal in a similar way. Why are metals strong? Metals are usually strong, not brittle. When a metal is heated, the layers of metal ions are able to slide over each other, and so the structure doesn't break. Here you can see a metal before its heat. And here metal after its heat. The metallic bonds don't break because the delocalized electrons are free to move throughout the structure. This also explains why metals are malleable, easy to shape, and ductile, can be drawn into wires. And what about corrosion? Corrosion is the gradual destruction of a metal due to reaction with other chemical in its environment. Over time, corrosion changes the appearance of the metal as it breaks down and it becomes weaker. Corrosion can seriously damage metallic objects and structures. Coating the surface of metal with paint and certain chemical can protect it from corrosion. And what happens if the protective coating becomes damaged? Do all metals corrode? Metals behave differently when exposed to the environment. Gold is an unreactive metal and doesn't corrode easily. In many cultures, gold is considered a precious metal and is used to make sacred and decorative objects. Items made from gold can survive for thousands of years and have even been found in good condition underwater. In general, objects made from metals that corrode easily do not survive for as long. And why doesn't aluminium corrode? Aluminium is a very reactive metal. However, it doesn't corrode in the presence of oxygen. And why is this? Oxygen in atmosphere, and this is aluminium atoms. When when coating of oxygen atoms, the aluminium atoms react with oxygen in the atmosphere, and this forms a thin layer of aluminium oxide on the metal surface, which protects the metal from corrosion. What is rusting? Rusting is the specific name given to the corrosion of iron. It's a chemical reaction between iron, oxygen, and water. This is a corrosion of iron. The chemical name for rust is hydrated iron oxide. Rust can form on cars and buildings, making them unsafe. and it's an expensive problem. Salt can increase the rate of rusting. This iron bolt is on a seaside structure and is nearly completely corroded. And what's the word equation for the formation of rust? Iron plus oxygen plus water equal hydrated iron oxide. And now you can see rate of corrosion experiment. Under what conditions will iron rust most? Under dried air, you can see a calcium chloride. Under air, you see a distilled water. Under layer of oil, you can see a boiled water, and under air, you can see a salt water. So, what do you think? Here, dried air and no water. So, no water, no rust. No rust. Here, nail in water and air. We have oxygen and water. So rusts quickly. Lots of rust. Rust quickly. Then a layer of oil we have and boiled water. Rust slowly. Because we have a layer of oil. Then this oil will in water. And salt water and air rust quickly. The next subtopic is processing metals. Finding metals. Are some metals easier to find than others? Gold or ferrum? I think you asked this question. So now I explained about it. Where do metals come from? Metals can be found in the earth's crust combined with other elements, or uncombined as pure substances. Some unreactive metals like gold, silver and copper can be found uncombined as elements. Metals that are found in a pure form are said to occur native. Most metals are actually found combined with other elements as compounds in ores. These metals must be extracted from their ores before they can be made useful. Highly reactive metals, such as titanium, require complicated extraction. This can increase the cost of the poor metal. And how does reactivity affect extraction? The reactivity of metal determines how it's extracted. Increasing reactivity. When we have increasing of reactivity, hydrogen, copper, silver, gold and platinum. All this metal under hydrogen. Platinum, gold, silver and copper can occur native and don't need to be extracted. Carbon, zinc, iron, lead. Metals below carbon can be extracted from their ores by reduction using carbon, coke or charcoal. And potassium, sodium, calcium, magnesium, aluminium. These metals above carbon in the reactivity series must be extracted using electrolysis. Electrolysis can also be used to purify copper. Very useful information about metals. Now I was explained. And how is carbon used to extract metals? Very interesting. Metals that are less reactive than carbon and can be extracted from their ores by burning with carbon. Iron is extracted by this method in the blast furnace. The iron ore is heated with carbon-rich coke at very high temperature. This is a molten iron. This is a molten slag. And this is a raw material that part here. The iron collected from a blast furnace is only 96% pure. So you can see hot air from these tubes, then heated with carbon-rich coke at very high temperatures. Usually this product will be treated future because the impurities make iron brittle. And what is electrolysis? Metals that are more reactive than carbon are extracted using electrolysis. This process uses an electrical current to extract the metal. Aluminium is extracted from its or bauxite using this method. Electrolysis is also used to further purify metals, such as copper, after extraction with carbon. Electrolysis is more expensive than using a blast furnace, and this increases the price of the metal. So, question: why are highly reactive metals extracted by electrolysis? Extraction of metals of high reactivity. Metals of high reactivity such as sodium, calcium, magnesium, aluminium, etc. are extracted from their ores by electrolytic reduction. These metals cannot be reduced using carbon because carbon is less reactive than them. And what is the order of reactivity of metals? The reactivity series lists metal compounds, including magnesium, sulfur, and lead, in their order of reactivity, with the least reactive at the top. Those at the top and bottom are most keen to react with other elements to form compounds. Less reactive metals will displace other metals from their compounds.